So I've opened the editor, p5.js editor, and I'm going to start a new sketch, and let's just do the stuff that we normally do with that. So we have to start with some global variables. We need one to hold the array of our circles, and we need one to hold the number of billows that are going to be in each cloud, or basically the density of the cloud. That's it for the global functions. In setup, we've got to do a little bit of preparation, and it's not much. I need a variable to handle the width and the height, something that I could pass to the object so it knows where to be a cloud at on the canvas. And it's just going to be the full width and the full height. I was thinking about this a little bit, why these aren't global variables. Why are they local variables? Well, I'm passing them into an object, so I could use that object's location, and then that's going to tell me the width and height. So I don't need it as a global variable. I can just use it from the object when the object establishes that as a value. I think that's why I did it this way. I'm just trying to keep my global variables down as much as I possibly can. So we're going to create a loop. That's what I've done here. And we're going to go through the number of billows that are going to be in our array, or the density of our cloud. And then we need to create the new instance of our cloud and push it into the array. So we are using our clouds variable, the array variable that we used up here. We're going to use it. We're using the dot syntax. We're using the push function. And then inside the parameters of push, that's where we're going to put whatever we want in that array. In this instance, it's going to be a new object. And that new object has parameters too. So we're going to put those in there. I think the first parameter in the cloud is the center of the cloud shape itself. And that's going to be its X and Y coordinates. And we know the width of the screen is W, and we want it to be half in the middle of the screen, so we're going to divide that by 2. And then we want it to be so far down from the top. So I'm just going to use a fraction of the height. So I'm going to take the height value, that let h equals height. I'm going to multiply that times a decimal, which will be a fraction. So 20% of the height is where this cloud is going to be located on the canvas. So let me drop down again so we can keep things a little bit clear. So I've got the X and Y location for where our cloud's going to be centered at. It needs an area, a range for the cloud shape to spread around in. And this is going to define pretty much how big our cloud is going to get. So I'm going to set that to 45, and it needs a minimum size for the cloud range. So in our noise value, we're going to map that returned value. So noise returns a value between 0 and 1, and it's a unit vector, so it's not useful on its own, but we can multiply it times something. If we do that in the map function, then we need a minimum range and a maximum range to map that 0 to 1 value to. So for the first value, I'm going to just be 0. So a cloud shape can be a minimum size of 0 and a maximum size of 150. And I think that's the radius. It could be the diameter. I don't know if I divide that by 2 or not. We'll find out later on in the code. But anyway, there's all your parameters. You have your X and Y position for your cloud. You have your area size that the cloud will be printed in. And then you have your minimum noise value and your maximum noise value. And that's the end of that loop. So now we're ready to go down into draw. So that was pretty fast so far. Not a lot to this. So let's set up the, we need a sun, we need a background. So we want the background to be blue like the sky. We need our sun to be positioned roughly where the cloud shape is. So let's work on that. I want to contain any changes to the graphic state. So I'm going to put my sun shape and its location inside push and pop. If you notice here, I've done this twice. This is width divided by height and height divided by 20. Why didn't I use the W and the H? Because these are local variables and I can't use them there. So why don't I make them global variables if I just have to type this again? Because you can see this right here is the same as this right here, except for there's 4 extra letters. Do those 4 extra letters mean that much to you? If you don't plan on having to change this, which I don't, I'm just going to put it in there like that. But I definitely could set this up a little bit better so that it's more robust. Right now it's not robust. If I make some kind of change to this value or that value or to this value or that value, then I've got to remember to make those changes to this. So you have to keep track of a lot. That's where setting up your variables right can save you a lot of time. But I'm not so worried about that, and I think it's okay where it is. But if you did notice that's a little strange, that's why. There's our sun, and I'm going to label that sun just so we know. And it's offset a little bit from its translation. So I've translated the sun's position to where our cloud is centered at. And then if I need to move that sun shape around, maybe I don't want it to be exactly in the middle of the cloud. Maybe I want it to be above the cloud a little bit so we can see the sun through it. Maybe I want it kicked off to the side a little bit, to the right or the left. So that's what I'm doing here. I'm translating it to that cloud's origin and then making whatever adjustments I need to its position in the X and Y of the circle parameter. So I'm actually kicking it off to the left a little bit and I'm dropping it down a little bit. So there's the sun, and I think if I did something like this, let's do this real quick so we can test this, see if it's working. So I'm going to put a function in here called CloudMaker, and it needs some parameters, some variables to receive the parameters I send into it when I instantiate it. And I'm not calling anything in the function update. I'm not doing that yet. So all I need is just this function to be here. So p5.js, when it looks for it, it's like, oh, okay, there you are. Let's pass the parameters into you. So I think that's it. So I'll explain the first part of this function while we're down here. The X and Y coordinate that I sent into it when I instantiated it, it's receiving it in XC and X and YC. The area is being received by the variable A, and the noise value's low side is the Z low and its high side is the Z high. I named it Z because that's the radius of the circle, and you can almost think of scale as like a Z value, so that's why I named it Z. Okay, let's go back up here and let's see if this will run. I have a feeling it will. And there we go. So we should have our sky and we should have our sun there. And I'm missing a stroke weight, I think. Yes, we need an outline here if we're going to have a stroke. There we go. And I think the outline's orange, the inside is yellow. There's those color values there. So this is what you should have so far if you're following along in the code. Okay. The next part of draw is we have to run through our loop of cloud objects that we made up in setup. So let's create that loop. So I have the loop that runs through the elements in the array, but I need an extra loop, and I'll explain that here in just a second. I'm going to put a loop that goes through 2 times. It's going to make 2 passes through this loop. So whenever I'm updating these circles, I'm going to pass to the function to the update function, I'm going to pass into it j, and it's going to have either a 0 or a 1 according to this loop here. Well, if it has a 0, I'm going to multiply that 0 times a color, or do some action like that, and it's going to make a dark color. It's going to create black in theory the first time through, and then the second time through it's going to make it white, let's say. So let's say my color is 255 and I'm multiplying it times j. The first time through it's going to multiply j times 0, so that color is going to be 0 or black, and then the next time through j is going to be 1, so that color is going to be 255 times 1, it's going to be white. So that's kind of the operation that's happening here. I want to be able to create two printings of this object, two layers. One is a bottom layer that's going to be slightly bigger, and then a top layer that's going to go over the top of it, and where there's the underlap on the bottom layer, you're going to be able to see it, and it's going to look like the outline of the object. Probably didn't explain that the best way. I explained it probably better in part 1, but I worked on that a little bit. So that's what we're doing here. We're going through the first loop so that we can figure out, let's print that first one, then let's print the second one. And then inside that J loop, that's where we're actually performing our cloud action at. So we don't need the J loop necessarily, but if you want these objects to be outlined, then that's going to be a handy way to do it. So we have all of our cloud units together as a cloud on the screen. Let's put some grass down there. So let's just go down here. We've printed our background, we've printed our sun, our clouds are going over the sun. So now we need some grass. Okay, so what's this do? I'm multiplying the height times a big number. So this is almost the height. This is almost 1 here, so this is almost the height, but not quite. So it's going to create a little sliver of grass at the bottom. So I want to take the height and subtract from the height that little sliver, or actually that big chunk, and it'll leave a little sliver. So if I go down to, let me see, let's get here, let's go into this function here and let's create another function called update. Let's learn how to do functions. Update equals a function. So now this should work, maybe. Oh no, it has to receive a value here, so we're going to put j there because that's the value it receives, just so I know in my brain. So if you run this program, this is the output that you should be getting. You have some grass at the bottom, you have a sun, and you have no cloud because there's nothing in this function yet. So let's do that. So I've started the function here. I've created the parameters, all the variables that this function's going to get when it's instantiated. So I can use these throughout the function. This j, I can only use it inside update. So if I need to use j in any other part of this function, like maybe I have a bounds or something, then I have to remember to pass it through. So just keeping what you need where, that's kind of an important thing to remember. Let's start this, and I'm not sure all these variables are necessary, but they're here and I'm using them. I probably could optimize this a lot, but this is what I have for the main function of this program. So if you can do a better job, please give it a try, and I'm sure you can, and your code will work better for you, but it works okay. Let's start with the radius that changes by the noise wave. And we're going to set that to start at the highest value. So we're going to give our x, that's going to be our random x position. This is the location within the bounded magnitude, that area. I said bounded magnitude, that bounded area that we increase by the magnitude in order to get the cloud to grow or shrink. So it has an origin in the center of that rectangle. And then if I pick a random number that's negative, I'm going to go to the left of that center, or in the left side of the rectangle area. And if it's a positive number, it's going to be in the right side. That's on the X. And then on the Y, it's going to be above it or below it if it's negative or positive. So keeping that in mind, if I wanted the cloud to be biased toward the bottom, if I want there to be more toward the bottom than the top, then I need to adjust how my random numbers are selected in that area. So that's what I'm doing here. The X, there's no bias. So I'm just going to take my area value from up here, and I'm going to plop that into the first range of this random value and give it a negative. And then I'm going to go on the other side of the origin, which would be the positive value A. For Y, I'm going to do it a little bit differently because I want the cloud to be stacked a little bit. So that's where I do this here. So now basically the cloud is going to be 1/2 the height of our rectangle that we're bounding it in. If I wanted it to be in the rectangle completely, then I would put negative A here. And there'd be an equal chance that there'd be a randomly placed circle in the top half of the rectangle as there is the bottom half of the rectangle. But I don't want that because then my cloud's going to look square. So I'm going to put a 0 there, and hopefully it's going to make our cloud look like it's kind of rounded a little bit. That's my theory, and I probably need to work on that a little bit because I don't think it shows up as well. But mess around with that and see what happens. See if you can get a better cloud shape to form. You might use vectors, so instead of having the Cartesian values, so the object's going to look like square because it's plotted to these Cartesian values. But if you plotted it to polar coordinates, it's not going to look square, it's going to look round. So you might play around with that and see the difference between Cartesian and polar coordinates and how the randomness of the placement of these circle units play out. So as the cloud shape grows, we want its radius to be able to expand. And so I need a value to hold that, a variable to hold that value. And I'm going to call that area range. I'm going to set it equal to 1 for now. Now we can start creating our position because we have the math to be able to place it inside the area and situate it on the canvas where it needs to be. So I want to take the X random value that I have. That's my unit vector. I'm going to multiply it times my magnitude, which is this A range. And then I'm going to add to it the position that it's supposed to be at on the screen. I'm going to do sort of the same thing for Y, except I'm going to subtract it from its position. And I'm only going to use the unit vector. I'm not going to multiply its magnitude. I probably need to, and I'm going to look at why I didn't. My notes don't really tell me that. So I'm going to go down here and see where I change it again. Okay, so that needs to change. Do I have the variables to change it though? No. That's why I didn't do that. Okay. This will be okay for now. But this isn't adequate. This is insufficient. This isn't the right coordinate. But it'll work for now. The reason why it's not insufficient is because I have to perform some more math on the position. Because I have to add do this magnitude thing to it. But I don't have the variables for that. So let's go down to the next variables and see what we can get to. So each rain cloud unit has a raindrop associated with it. So when its state changes to rain, it just lets go of that raindrop. Well, that raindrop needs to know where it's at. So I just give it the parent position. So the cloud unit's position. I just copied it to the raindrops position. So I need an offset for the noise. That's what this does. And I want the noise to be separated. I don't want there to be a lot of relationship between the cloud units, radius, and the noise. So I'm going to multiply that offset times a random number, and hopefully I'll get cloud shapes that move at different rates. I need a variable to hold that noise value. And I want to take the parameter and assign it to a function variable for the minimum size and maximum size of the radius, or actually the wave noise. I need a range for the scale of things to be in. I need something that moves back and forth, this oscillator. And then I'm going to multiply that times the area range value, this thing here. I'm going to multiply a number times that in order to get things to grow and not grow, grow and shrink, grow and shrink. Okay, that might seem redundant that I did this up here and then did that down there. But I had to use a range in order to get the unit vectors for the position, and I wanted that to be a unit vector, so I just set that to 1. Now I need to set that unit vector to maybe a fraction or a multiple that's set to the noise that I'm scaling things to, this magnitude value. So that's what I'm doing here. And ZR, this is my polarity for my range, my Z range polarity. It's going to be oscillating positively and then negatively. So I need a variable that I can multiply times -1 to get it to switch back and forth. So that's what I'm doing there. And then I'm setting that increment or decrement value to, and it's decreasing to begin with. So now I need to handle my raindrops. They need some parameter or some variables. They need a velocity. So this is how fast the raindrops fall, this is how fast the raindrops fall, 3 pixels per frame, and then they're moving to the right a half a pixel per frame. So it looks like the little bit of wind. So whenever a raindrop gets activated, I just add its velocity. I just fix its velocity to whatever it needs to be. And rain is not falling to begin with because the state of my magnitude is at its lowest value. So I know that the state of the cloud is its smallest. It's not raining then. It's only going to be raining when it gets bigger. So I know that this state needs to be false to begin with. So I think that's all of our variables for the instance of our cloud. So now we need to create the functions that go inside our function, the methods. We have this method called update, and that's the one that we call in draw. You can see here in the loop. So we have our element in that array, and we're looking at its update, its specific update function. And it's being updated using these variables. The very first thing I want to do is increase or decrease, depending on the polarity, the magnitude of the area and the magnitude of the wave that's creating the radiuses. In my noise function later on down in the program, it's limited, it's constrained by the Z minimum value and the Z maximum value. So if I want to change the magnitude of that noise, I need to affect that Z maximum value. So that's what I'm going to do in this line here. I need to, my A range needs to be, the area range needs to reflect that change in the Z max so that they're relational, so that the radiuses get crazier as the area gets bigger. So the next thing I want to do is take my area range variable I'm going to multiply something times a fraction. I want things to be in smaller scale, like maybe the wave value doesn't need to be the same number as the area. So I need to make this adjustment. So that's what this is doing here. What numbers am I using? Well, I'm using my constraint for the noise, that Z max value, and I'm going to subtract from it this Z range, this magnitude value, and I'm multiplying that times a fraction, and that's going to give me my area range. It'll become more apparent why this is so later on once I get into the noise function. So now I want to do the real scary stuff of setting this position, and hopefully I'll understand what I did. I have some notes, but they're not usually the best. So I'm going to use the A range as the magnitude for the cloud unit rotations, and that's going to be related to the cloud shape's center position. So let's do that. Okay, this is the x coordinate. What are we doing so far? Let's look at this first variable here, this dot x, this dot rx. That's our unit value for the location of our cloud unit's x position. We're just taking that unit value and we're multiplying it times the magnitude. And this has been adjusted by an oscillator. And then we're adding that to the x location. So that makes sense so far? And we're going to do the same thing with the y. This is where I said up there the y position was inadequate. Now we're going to make it sufficient. We're going to take that unit vector, we're going to multiply it times the quantity of a fraction of the range. The reason why I do this is because I want the cloud shape to be larger than it is tall, like wider than it is tall. I don't want it to be like a cube or a square. I want it to be more like a rectangle. So I need to do that to its unit vector in order to make that work. So what I do is I take the quantity of the area range and then I multiply that times a number half. So it's basically half the height as it is. It's twice as wide as it is tall. Okay, and then I'm subtracting it from the center, and then I'm adding to that position the noise maximum range times 3/4 of that. 1 3/4 of that. I'm going to check something out later. Let's just work with that for now. This is the terrifying math that is this problem right now. I did that for a reason, and it must have just been kind of like fine-tuning it, trying to get it to look like it's growing in the right way. It may have been one of these cases where when it was growing, it was just pushing the cloud downward as it grows, and I wanted it to grow out of the center. So that might be something along that line, so that it's not just moving away from the center point in one direction. Because I can't really use rectangle mode on my shape. I have to perform that actual operation to get the center and everything to work with the center. So that might be what that is. If you know what I did, because I apparently don't, let me know in the comments. Does that happen to you as a coder? All right, let's move on to the next thing before this video is 10 hours long. So I'm going to look at the Z range and see, and I'm going to bound it. If it gets too far to one end, I'm going to reverse its polarity and it's going to go back down to the other end. So let's do that. And Z range is bounded to the noise constraint. So if I'm out of bounds, I'm just going to go the other way. So now everything's cool. We have the right numbers. Now we're ready to start doing this noise, moving through the noise function. That's what we need, an offset for our noise. I call it Z offset, but I'm probably going to use it in like the X parameter of the noise. Those are kind of arbitrary. It depends on what you're using them for, what you can call them, or where you need to get them from. But by and large, X in the first position, Y in the second, and Z in the third can be arbitrary. This is our noise wave right here, and it's being mapped. So let me spread this stuff out a little bit so you can see what's happening. And let me drop that down so it makes a little bit more sense. Okay, so here's our map function right here, and it has some parameters inside it. We're going to put the first parameter is going to be our noise function, and then the second parameter is the lowest range of what we can expect this value to be, and this will be the highest range of what we can expect this value to be. So the noise function returns a value from 0 to 1, so we know this is going to be 0 to 1. If I had any other value in there, and I know that its range is going to be like 0 to 255, well then I'd put 0 there and 255. If it's going to be negative 500 to positive 500, well then it'd be negative 500 here, positive 500 there. So you see how that works, the first range values. Well then we're going to, I think it's interpolate. We're going to associate what is the 0 value from this range proportional to the 0 value of this range. So our second set of values is the corresponding low end and the corresponding high end right here. So when this is 1, map will return this value, and when this value is 0, map will return this value, and then proportionally any values in between. So 0.00001 is going to be this value factored to be 0.001, and it's not going to equal 0.001, it's going to equal a factor of that. So that's what map is doing. We only have one value in our noise function, because that's really all I need, is I just need that example, that object moving back and forth, that single object moving back and forth. But instead of using the math to move it back and forth, I'm going to use the math to increase and decrease its radius. So that's what we're doing here. And the radius is going to be constrained to a minimum size of this value and a maximum size of this value, subtracting the oscillator value. So it's constrained, it's doubly constrained. Depending on what state it's in, it's going to have a larger or a smaller Z max. So Z range is really kind of related to the state the cloud is in. So let's remember that. It's going to become important in the future. So we have our noise function, and now we need to assign that value that we've received from map. We're going to give that to the radius of our circle. So the variable Z wave is receiving the value from the map function, and we're passing that value into the radius of our circle. So I'm not going to get into the rain just yet. Let's work on the clouds first. And I think I have everything to make my clouds now. Okay, yes, I think I have everything to do our clouds. So we'll do the rain here in a little bit. If you're programming this, if you're going through the list, right here is where you would put your rain, because we want our rain to be printed behind our cloud. So I'm going to just put that annotation there so we know when we go back that's where we're going to put our rain. Let's make our clouds. We're going to encapsulate any transformations, any changes to the graphic state. We're going to put that in push and pop. And the very first thing we're going to do is translate to our cloud's position, our cloud unit's position. Normally I would put the fill color here just out in the open, but we've passed into this method the variable j. We've passed that into this method for a reason. This is where we handle that at. So we're going to look at j, and we're going to see what j is doing. And if j equals 0, this is the first pass through, then we're going to handle the circle one way. And if j equals 1, we're going to handle it in a different way. So the first state, this is the background which is going to form the outline of our cloud. So I need that shape to be a little bit larger. So when I get into the radius of this circle, I want to take its radius and I want to add to it a proportional amount. So I'm going to take the z max value and multiply it times a fraction, and that's going to give me a slightly larger circle if j equals 0. So what if j doesn't equal 0? I could put an else here. I'm just going to put another condition. Okay. I can't just fill it with any color because the outline is going to stay a constant color. So the first time I print this fill can be a constant. But if the cloud changes states, if it's getting ready to rain, I want it to be gray. So the second pass, when the cloud is white, I want it to be able to not be white. I want it to be gray or whatever, right? So let's handle that. So we need to look at maybe mapping the range. So if we use that map value and we look at what range our area is in, then we know what if the cloud's big enough to be gray or whatever. So let's do that here. I'm going to create a local variable. I call it a scope variable because that's the area you get. That's the error you get when you use it wrong. So my color range is going from 125 to 355. And you're like, well, there is no 355 color. It's like, okay, yeah, you're right. If it is over 255, it's going to automatically assume 255. So basically all I'm doing is making 100 assumptions that this cloud's going to be white. And then the lowest color it's going to be is 125. That'll be like the darkest gray it will get. No, that's wrong. Forget what I just told you. Okay, yeah, that is right. Remember what I just told you. I was afraid that I was subtracting this from 225, which this would be the exact opposite of what I just told you. But I'm not doing that in this case. So it is true. I could reverse that. When the cloud is small, it's gray, and when it's giant, it's white. But that wouldn't make sense. But I could do that just by changing the math a little bit. So let's put the fill in. And it's going to be that variable, that local variable we just made, maximum intensity. So it could be gray or white. And now let's draw that circle. And we don't have to make any adjustments on its size. It can be its regular size so that it leaves a little bit of the edge of the circles underneath it that I printed up there when it was at 0, when j was 0. I printed a larger circle. And then when j is 1, over the top of that larger circle, I'm printing the same circle, just a little bit smaller. And it has a different color. So that's the end of that there. Now if I did everything, if I didn't forget something important, hopefully I didn't. Let me go back up here to the draw and make sure that I've just included only what I need to include. Okay, let's run this and see what happens. See if a big nasty error happens. Okay, so if you've typed this code in just as I have shown you here, you should have this output. Now, do you want to make it rain? If you want to make it rain, you can continue on this video. Otherwise, you're good to go right now. You can make this cloud do what you want. Take on the challenge of making raindrops here. And then maybe watch the end of the video and see how I did it. See how it matches up. That's kind of fun. There's lots of different ways of doing just about anything on a computer with code. There are what people would call the optimal ways, and then there are the sloppier, maybe extra stuff, stuff you don't need, the more real world hobby coding. Because hobby codists, we're just trying to learn things and achieve goals, meet these challenges just to amuse ourselves. So it's not about trying to be perfect and having the most optimal code. It's about trying to get done what you want to get done and learning in the process. So I hope you've learned something from this. If you want to do the rain, stick around. If not, thanks for watching. I appreciate it. Oh, and let me know what you think. So let's do the rain. We're ready to put in the rain, so let's find our annotation in here. Put rain here. So let's make rain if big enough. We want our raindrops to kind of always be hidden behind their parent cloud. And when they let go, they're going to move along behind their parent cloud until they pop out. And if there's clouds in front of that parent cloud, then you're not going to see it until it comes out of the very bottom of the cloud. But sometimes you might see the drop come out of the middle of the cloud. So I kind of like that idea. So let's keep that in mind when we're doing this. To make rain, the first thing we need to do is a condition to test to see if the cloud is large enough. So we're going to look at the area range, and if it's a certain size, then we know it's enough to rain. Okay, I think that's what we need to make rain. We have our condition here. The cloud is big enough, the area that it's in, or the cloud shape is big enough that we want rain to come out of it. Well, then we're going to look and see, we don't want all the clouds to just dump rain at one time. We want one to maybe decide to drop and then look at the next cloud unit. Did you want to drop yours? Nah. And just go through the whole cloud like that. So how we do that is I'm going to create a local variable called yesRain, and it's going to equal a value 0 to 1, or almost 1. Then I'm going to look at that value and see if it's below a certain range, and if it is, then I'm going to let the rain fall. And in this case, it's, let me see, this would be 1, 10, 1. So there's not much of a chance for rain to fall. This is going to spread the drops out so that they don't look like they're all dumping rain at one time. You can play around with this number to get whatever look you're after. And I'm not just looking at that random value to see if it's okay to rain. I want to look at the raindrop and see if it's okay to rain. So I don't want to make a raindrop okay to rain if it's already raining. I want to wait till it's done falling and being rain before I check and see, am I going to let go of you again? So that's what this is doing. If that rain isn't falling, then we're going to make it fall. And we're going to set its starting position to the cloud's position. So that's what these variables do here. So I need another condition here that looks at the rain. If it's, so I have this state here, this dot rainfall, this boolean, it's set from false. Now it's going to true. I've set it to true now. What does that mean? Well, let's handle it. Let's look and see if that's true, and if it is, then let's do the rainfall stuff. So that's kind of a switch that's turning the rain on and off. So I want to translate to the raindrop's X and Y position. I'm making a point instead of an ellipse. I want my drop size to increase according to how bad the storm is. So what the state of the storm is in is going to define how big these drop sizes are. And I can do that by creating a local variable called drop size. And I want to map that value. I want that to be the return of the map of the range, the area range, which is a number between 0 and 3.7, I think. And then I'm mapping that to -6 and 6 because I want the drops to just fade into nothing. And I want them to be there for a while. It will make sense. If you play around with these, it will make sense what that does. It's kind of hard for me to explain, but that's what it's for. So once I have my drop size, I put that to the stroke weight and I add it to a minimum stroke weight. And it's going to be a negative value at some point. So this isn't going to matter so much. It's eventually going to be, it's going to disappear. And then you can play around with this value to make it disappear at certain points, or, you know, get to a certain size at certain points. And then just make your point at 0, 0, which is the origin you've translated the positions to. Now we want to create a local variable that's going to handle the color of our rain. And we may as well map this to the state. So I want the alpha of the rain, I want it to look like heavy, stark, you can clearly see it, to being small and faded, and you can't see it so well for light rain. So that's what that effect is trying to achieve there. You can mess around with that and see what you can get to happen. You might not like the way that I did my rain, so you might want to change it, and that would be how you could go about doing it. So we're going to create our stroke color. Did I not use the color in there? You know, that must be a holdover. So if you want to use a color changer, you can. I just decided not to. I just made it straight blue there. You can put the R color value in there somewhere. Drop size. Okay. So our bottom drop is a little bit larger, and then our top drop is a little bit smaller. I think that's what's happening there. And then let's just print that one over the top of it, and then close our pop. Well, once we've created our rain, once we've made a raindrop, let's handle how raindrops move and when they're in bounds or not. So I'm going to create a method inside this function called this.rain, and I've called it inside the update function. So now I need to go down here to the bottom of our update function. I think that's the end of it. So I'm still inside the CloudMaker function. I'm at the bottom of the update function. I'm going to create another method called this.rain. It's a function, and it's going to have a condition in it that handles how the rain moves, and it's going to have a condition in it for when it gets off of the screen. So I'm moving the rain. I'm basically updating the raindrop here. And then inside that condition where I'm updating the raindrop, I want another condition to see if it's out of range. And if it is, then I'm going to change the position of the raindrop is going to go back to its parent. Remember the cloud's position is this.pause. So if I copy that and put it into this.rainpause, now the raindrop is at the cloud's position, hiding behind it. But that's not good enough because it's going to fall again immediately, which I don't want it to do. I want it to sit there and wait and see if it meets that probability to fall. So I'm going to set its state back to false. And now it's going to get another chance. Do you want to fall? Nah, go on to the next guy. But if that's true, it's not going to get the chance. Do you want to fall? It's like, oh, I'm falling already. You know, it's going to be like that. All right, so let me see. Do I have 4, 5, 10 brackets at the end of this? 1, 2, 3, 4. Okay, so let me just check this. I've got the end of that internal if. I have the outside if. I've got the function. I've got the main function. All right, that's all of the program. Now, if we run this, hopefully it works. We haven't run into any problems. We're not going to know if it works or not until it starts to rain. So don't get excited yet. Let's see if some raindrops fall out of this. It's turning gray. That's a good sign. It's changing color. I see a little bit of rain, but doesn't look very apparent. There, it's more apparent now. You can see now it's really light rain. So there you go. We've just made a rain cloud. Now my challenge to you is to make another function that displays the state of the cloud that says whether it's sunny, partly cloudy, cloudy, rainy, or heavy rain. That's my challenge to you. Be kind of fun to do. I think you can do it. I have confidence in you. I hope you've enjoyed this episode. I hope this code has worked for you and you find some good in it and you're able to create some more challenges and have some fun with it. It is a really fun program, and I've learned a lot in making it, and I've also learned a lot in trying to explain it to you guys. If you like this video, give me a thumbs up. If you like this series, give me a thumbs up, and hit subscribe, hit the bell if you haven't, to see more videos like this. Alright, well, until next time, you guys, as always, take care.